Yes, 14 THHN wire and 18-2 TP wire can be run in the same conduit. Here are some important considerations. Firstly, conduit size is important. Make sure the conduit has enough space for both the 14 THHN and the 18-2 TP wires. To find out if it does, check the conduit fill chart for the type and size of the conduit being used. Secondly, voltage drop is an important point. Voltage drop is affected by wire size, how long the wire is, and how much current is flowing through it. The 14 THHN wire is thicker than the 18-2 TP wire. This means it will have less voltage drop. Because of this, the 24-volt power to the electric valve should not have a big voltage drop along the conduit's length. Thirdly, grouping is something to think about. It is generally recommended to group wires together based on what they do and what voltage they are. In this case, the 14 THHN wire and the 18-2 TP wire do different things and have different voltage levels. They can be put together in the conduit, but it is not a requirement. There are also other things to consider. Firstly, make sure to use the right wire connectors to connect the wires to each other and to whatever devices they are connecting to. Secondly, make sure the wires are secured well inside the conduit. This will stop them from moving around or getting damaged. Thirdly, protect the wires from getting wet and from extreme temperatures. Overall, it is okay to run 14 THHN and 18-2 TP wires in the same conduit. Just keep the above things in mind. The 14 THHN wire should work well for carrying 24 volts to the electric valves, and the voltage drop should not be much. Let's delve deeper into each of these aspects to provide a more comprehensive understanding. Regarding conduit size, the National Electrical Code, or NEC, provides guidelines on how many conductors can be placed inside a conduit of a specific size. These guidelines are crucial for preventing overheating and ensuring the safety of the electrical system. The NEC tables, such as those found in Chapter 9, provide the maximum allowable fill for various conduit types based on the size and type of conductors being used. When calculating conduit fill, it's important to consider not only the cross-sectional area of the conductors but also the type of insulation. THHN insulation, for example, has different properties than TP insulation, which can affect the overall heat dissipation within the conduit. Therefore, it's essential to consult the appropriate NEC tables and perform the necessary calculations to ensure that the conduit is not overfilled. Overfilling a conduit can lead to several problems, including reduced airflow, increased heat buildup, and potential damage to the conductors. In extreme cases, it can even result in a fire hazard. Therefore, it's always best to err on the side of caution and use a larger conduit size if there's any doubt about whether the conductors will fit properly. Regarding voltage drop, it's a critical consideration in any electrical system, especially when dealing with low voltage circuits like the 24-volt system powering the electric valves. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. The amount of voltage drop depends on several factors, including the length of the wire, the gauge of the wire, and the amount of current flowing through the wire. As the current flows through the wire, it encounters resistance, which causes a portion of the voltage to be lost. If the voltage drop is too high, it can cause the electric valves to malfunction or not operate at all. To minimize voltage drop, it's important to use the correct wire gauge for the application. Larger wire gauges have lower resistance, which means they will have less voltage drop over a given distance. The NEC provides guidelines on the maximum allowable voltage drop for various types of circuits. For example, the NEC recommends that the voltage drop on branch circuits should not exceed 3%, and the voltage drop on feeder circuits should not exceed 5%. To calculate voltage drop, you can use Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance. The resistance of the wire can be found in the NEC tables based on the wire gauge and type of conductor. By calculating the voltage drop, you can determine whether the wire gauge is adequate for the application and make adjustments as needed. In the case of the 14 THHN wire, it is thicker than the 18-2 TP wire, which means it will have less resistance and therefore less voltage drop. This is particularly important for the 24-volt system powering the electric valves, as even a small amount of voltage drop can affect their performance. Regarding grouping of wires, while it is generally acceptable to group wires with different purposes and voltage levels in the same conduit, there are a few considerations to keep in mind. Firstly, it's important to ensure that the wires are properly insulated to prevent any accidental shorts or ground faults. THHN insulation is designed to withstand high temperatures and is resistant to moisture and chemicals, making it a suitable choice for most applications. However, it's still important to inspect the insulation regularly to ensure that it is in good condition. Secondly, it's important to consider the potential for electromagnetic interference, or EMI. EMI can occur when the electromagnetic fields generated by one wire interfere with the signals in another wire. This can be a particular problem when dealing with sensitive electronic equipment or control systems. To minimize EMI, it's recommended to separate the wires as much as possible and use shielded cables where necessary. Shielded cables have a layer of conductive material that helps to block out EMI. Thirdly, it's important to consider the potential for harmonic currents. Harmonic currents are currents that are multiples of the fundamental frequency of the electrical system. They can be caused by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonic currents can cause a number of problems, including overheating of conductors and equipment, increased voltage distortion, and interference with sensitive electronic equipment. To mitigate the effects of harmonic currents, it's recommended to use harmonic filters and oversized conductors. In the case of the 14 THHN and 18-2 TP wires, the potential for EMI and harmonic currents is likely to be minimal, as they are serving different purposes and have different voltage levels. However, it's still important to be aware of these potential issues and take steps to mitigate them if necessary. Regarding other considerations, using proper wire connectors is essential for ensuring a safe and reliable electrical connection. Wire connectors are used to join two or more wires together and provide a secure and insulated connection. There are many different types of wire connectors available, each designed for a specific application. Some common types of wire connectors include wire nuts, crimp connectors, and push-in connectors. Wire nuts are commonly used for joining solid or stranded wires in junction boxes. Crimp connectors are used for joining wires by crimping them together using a special tool. Push-in connectors are used for joining solid wires by simply pushing them into the connector. When selecting wire connectors, it's important to choose ones that are rated for the voltage and current of the circuit. It's also important to choose connectors that are compatible with the type of wire being used. For example, some connectors are designed for use with copper wire, while others are designed for use with aluminum wire. When installing wire connectors, it's important to follow the manufacturer's instructions carefully. Make sure the wires are stripped to the correct length and that the connectors are properly tightened. A loose or improperly installed wire connector can cause a number of problems, including overheating, arcing, and even a fire hazard. Securing the wires adequately within the conduit is also important for preventing damage and ensuring the longevity of the electrical system. Wires can be secured using a variety of methods, including cable ties, clamps, and staples. Cable ties are commonly used for bundling wires together and keeping them organized. Clamps are used for securing wires to the inside of the conduit. Staples are used for securing wires to wooden surfaces. When securing wires, it's important to avoid over-tightening or damaging the insulation. Over-tightening can cause the wires to become constricted, which can reduce their current carrying capacity. Damaging the insulation can expose the conductors, which can create a shock hazard. Protecting the wires from moisture and extreme temperatures is also crucial for maintaining the integrity of the electrical system. Moisture can corrode the conductors and insulation, which can lead to shorts, ground faults, and other problems. Extreme temperatures can cause the insulation to break down, which can also lead to problems. To protect the wires from moisture, it's important to use waterproof connectors and seal any openings in the conduit. To protect the wires from extreme temperatures, it's important to use wires and connectors that are rated for the operating temperature of the environment. In conclusion, while it is generally acceptable to run 14 THHN and 18-2 TP wires in the same conduit, it's important to consider the various factors discussed above to ensure a safe and reliable electrical system. By following the NEC guidelines and using proper wiring practices, you can minimize the risk of problems and ensure that the electrical system operates efficiently and safely. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical wiring. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It is updated every 3 years by the National Fire Protection Association, or NFPA, and is widely adopted throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, engineers, and anyone involved in electrical work. The NEC is divided into chapters, articles, and sections. Each chapter covers a specific area of electrical installations, such as wiring methods or grounding. Each article covers a specific topic within that area, such as conduit fill or voltage drop. Each section provides specific requirements or recommendations for that topic. The NEC is a complex document, and it can be difficult to understand and apply. However, it is essential to follow the NEC guidelines to ensure the safety and reliability of electrical installations. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. In addition to the NEC, there are also a number of other standards and guidelines that may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be familiar with all of the applicable standards and guidelines when designing and installing electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before undertaking any electrical work. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure our safety and the safety of others. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you.